Good afternoon, everyone. Um, in this lecture, we're going to be introducing B trees, learning basic concepts about B trees. So what about B trees? Basically, you have seen in previous lectures basic tree concept, a root node having children. Now, B trees are balanced binary trees. There are certain applications where these are very useful. For example, secondary storage, hard disks, database systems where you need more data to be accessed, and you can't keep all data in main memory because your main memory is limited. So what happens that the B-tree algorithm, it keeps the pages size are big, and one page at a time, or 2 or 3 pages depending upon the operating system, how it is being configured, is being brought into the main memory from the secondary storage. So this is a very useful data structure. And so in this lecture, we're going to be discussing about basic concepts. Okay, so for example, if you have n node B tree, it will have height of in the order of log n. What it means that the many operations, dynamic set operations, you can execute in log n time. Okay, now each internal node contains a number of keys which acts as a separation of values which divides a subtree. For example, this figure shows an internal node which has keys 3 and 7. Okay, 2 keys 3 and 7. Now, how many subtrees or how many children it will have? It will have children 2 plus 1. Okay, 3 children. Now in these 3 children, the leftmost subtree will have values less than 3. Okay, now in the middle subtree it will have greater than 3 and less than 7. Okay, so, or in other words, I should say values, key values here would be, say, key values here for the middle children would be greater than 3 and less than 7. Okay, and the rightmost would be greater than 7. Okay, internal node x containing x dot n keys is just representing the number. So for example, for 3 and for this internal node x dot n it would be 2. Okay. Right, so think about if you have in main memory, if you have only 1000 keys. Okay, now you are storing in your main memory only 1000 keys. So how many children it will have? It will have 1000 plus 1 children, right? And similarly here you will have each children will have 1000 keys and so on. So these will have again 1001, 1001 subchildren. So think about at the height 2, this is 1, and if you have one more level here, so at this height you can have keys. More than 1 billion. So think about the usefulness of these B trees. These are very useful when for certain applications, as we said earlier, for secondary storage devices or databases. Okay. Now, the interesting property here is that, say, if you have two keys K1 and K2, then it's left subtree. We already discussed that K1, all keys will be less than K1. Okay, middle values between K1 and K2, and rightmost greater than K2. Let's have a look at a bit more general idea about B trees. So these are rooted trees. Let's say you have only one key at a root, okay, for simplicity, and it will have two children, okay. And now these two children each will have t minus 1 keys. Now what is t here? T is nothing but the degree of the B tree, minimum degree of the B tree. It's a positive integer. So see how it is expanding. You can expand the tree. And what it means here is that if you are at depth 0 at root level, you have number of nodes 1. But if you are at level 1, here you will have 2. Now at level 2 you have 2t, and see how exponentially this is expanding. Number of nodes are expanding in this tree. 2t square at level 3. I haven't drawn, but can be drawn. So what are the essential points we can note about B trees? That each node will have these properties. Okay, so you will have to store this information for each node, that number of keys, how many keys each node will have, what are the values of the keys in increasing order, and whether this internal each node is leaf node or not. It's true or false. So this is the minimum information for each node you will have to store. Along with each node will have pointer to its children. Okay, each internal node will have xn plus 1 pointers. So here we have only one, so we have two, one pointer here and one pointer here. Okay, 2 pointers. Now as t is nothing but we can put a upper bound and lower bound on how many keys this node will have, and a fixed integer greater than or equal to 2 is called minimum degree of B tree. What it means that every node other than root must have at least t minus 1 keys. All right, and at most a node can have 2t minus 1 keys, and if a node has 2t minus 1 key, we call it that node is full. All right, simple enough. So this was a quick introduction about B trees. Thank you very much. In the next lecture, we're going to be discussing about how to construct B trees, basic operations on B trees. So don't forget to watch the next lesson. And if you are struggling with algorithm subject, you may contact us for private lessons. And do not forget to subscribe LeProFesseur YouTube channel. I hope you all the best. Have a good day.